No, hello, Professor. My name is Dustin Phan, a student in your Text 174-9553 class. I'm here to demonstrate to you my code for the War Project 5. First thing we're going to be doing is to import a random function so we can actually shuffle a deck, and then define some global variables, most importantly, a list of values that we can use to instantiate the deck, the battle decks for the user and computer, the number of battles that have been played, as well as the battles that the user has won, as well as the completion state to know whether the game has ended or not. First thing we're going to do is instantiate the deck by using two for loops to append onto the empty deck. Then we'll shove that deck into a shuffle function, which switches two random indexes around by creating a tracking deck so we can swap index I and index j and index k together, removing each of those repeat values until there's none left, or 26 iterations. Once that will be returned into a split deck function, which will split the first half of said deck for the user and second half of the deck to the computer. Then we'll go to the other functions is the print deck function, which will basically create a copy of whatever deck argument we put in, sort the deck by throwing it into sort deck function, which is a simple deck.sort, and then print the sorted deck. We also have a distribute cards function, which will determine the number of cards to distribute, as well as who to distribute them to. We have a winner, war state, and end parameters. Whoever the winner is, which is the input that we'll give the computer, we'll add the cards to the back of the said battle deck. The war state is here to determine whether or not the nature of the card giving is in a war or if it's a normal battle, while end determines the amount of cards to give in the case that it is a war. As you can see here, we added the decks to the back of the winner deck and then erased said cards in the front. So there'll always be 52 cards in total. Then there's the battles function, where we'll take the first card of the deck and determine who has the higher value. I've made an exception specifically for A2 ace or 1 value to automatically win any battle, provided that the opponent doesn't also have a 1, as this right here demonstrates. We'll call the dispute battle if you, in the case that you have a higher value deck or you have a 1, set war state to false, and this value is irrelevant, but I'm going to put in 1 so I don't get a null. Same will be done for the computer here. And in the case of war, we will keep the war in a while loop so we can repeatedly use war in the case that we keep getting matching cards, only leaving if war is ever set to false. Here, and the code here will work the same way, but instead of doing the first card, we'll do 4 plus n, where n is the amount of additional cards played in the case of reiteration. This value over here is meant to determine whether or not the opponent actually has enough cards to actually play, and will forcefully quit you out in the case that you forcefully end the game in the case that the opponent or you doesn't have enough cards to complete the war. It'll also call that endgame function as well if you have 0 cards after a simple battle. We have a display statistics function, which will demonstrate to you will divide the amount of battles that you won by the battle number, making sure to avoid dividing by 0 by having this if-else statement. A print deck function, which will print the amount of cards that you and your opponent have. An end game function to tell you who won or lost the game, with also displaying everything so you get a good idea on how you were doing upon your win/lost. And then a reset function, reset the entire game, clearing all her decks, the statistics, sending completion back to false, and reinitializing the deck. Now we have the main menu. It'll first move to this function here, which will ask you to make a choice, using a while loop to make you repeat it in the case that you didn't type it in correctly. And then this if-elif branch to call the right functions, with typing play leading to battle, display score leading to the display score function, display cards to the print deck functions for both user and computer, win percentage leading to display statistics, win leading to completion equals true, and continue equals false. I added the win function specifically to allow me to speed up the game. Now, if completion is set to true, it'll actually go through this function, which I didn't talk about earlier, which will basically ask whether or not they want to play again using similar methods to this one right here. If you choose yes, I'll call the reset function, else it'll set continue to false, and you'll get kicked out the loop, ignoring these two. Now it's time to play the game. First, we'll demonstrate that the reset function works. First, we'll display our cards. And this is what my deck, the user, and the computer's deck looks like. Now I'll type win and then reset the game. Then I'll type display cards again. And as you can see, alright, it was just coincidence. Anyways, yeah, as you can see, the deck has indeed been resetted. So now we know that the reset function works. I'm going to call display score to show that we have 26 cards. Display statistics, and it'll show the no, it's not display statistics. Display no, it's win percentage. Win percentage, and it just says we didn't do any battles. Now we'll play, and I lost the battle. We'll keep playing till I get an ace or a war, in which case I'll explain that. Yeah, I have an ace and I won, even though my value is less. Now we have a 6v6, we just went into a war. I have 13, he has 9, and I won the war. Now I'll go to display cards. And as you can see, I've won the majority of the battles. So I have the majority of the cards, as I say. This is also corroborated by the display score, which still equals 52. Win percentage, and it shows. Okay, so it seems like I lost the majority of the battles, but because I won the war game, I managed to have more cards, even though my win percentage is very low. Now for the final function we'll test is the quit. And we quit the program. So this is my game of war. Thank you for listening to my presentation. Sorry if I spoke fast. I have a 15-minute time limit to record this thing. And I'll see you later. Thank you and goodbye.